Alrighty, graphing imaginary numbers and finding the imaginary numbers or complex numbers absolute value is really just finding the distance that point is from the origin on the grid here. So at number 23, here is my complex number. And it looks like 1, 2, 3, 4, 5. -5 on the real axis, and then down 1. We could write it like this, or if we'd like this. So that is identifying the complex number. And now the absolute value denoted is not like the normal absolute value. It's really taking the distance it is. So this is 5 from the origin along the real, 1, and so we complete this. So the square root of 25 plus 1, best answer, this is square root of 26 or 5 point something. Over here, similarly, here's this point. Looks like it's 2 and 1, so this point is going to be -2 for the real, plus 1 for the imaginary. And now the absolute value of that is going to lead to a square root of -2 squared plus 1 squared. So that's going to give me 4 plus 1 square root of 5. It's a good answer. Moving on to find the discriminant. The discriminant, denoted big D, as b squared minus 4ac once our equation of the quadratic is in standard form. This isn't quite there yet. I'm going to just rewrite it. I'm going to add the 2 over to give me this. My A coefficient is -1, my B coefficient is -4, and my C coefficient is also -4. So now D equals -4 squared minus 4 times my A coefficient times my C coefficient. Negative times negative is positive. I'm going to take care of that here. I'm going to get 16 minus 16, which equals 0. If your discriminant equals 0, you're going to have one real solution. It's really a double solution, we call it, or a double root. Over here, pretty close to the same type. I'm going to add the 9 over, so I'm going to get a plus 1. My A is 7, my B is 2, and my C is 1, respectively, for my coefficients. The discriminant will equal B squared minus 4 times A times C. So I get D equals 4 minus 28 for -26. Since my discriminant is negative, that means I'm going to have 2 imaginary solutions, because I would have that I number coming out of the radical. Remember, this discriminant is the part under the radical. Now, solve each equation by completing the square. There's just one of them. Again here, I'm going to do my first step. Since I have a 1 coefficient, it's kind of straightforward here. I'm going to put a blank here. I've added that 4 over, and I'm going to put a blank there. 20 divided by 2 squared is 10 squared, which is 100. So I'm going to put 100 here. What I do to one side, I have to do to the other. My squared binomial now is A plus 10. Over here I get 104. Now from here we do the solving steps when solving with square roots. I'm going to square root both sides. A plus 10 equals plus or minus the square root of 104. I can subtract the 10 over. So I get A equals negative 10 plus or minus the square root of 104. A couple ways I can go from here. I can just keep it in radical form. If I do that, this is fine. This is 4 times 26. Square root, so I'd get 2 root 26. If I would calculate this, either now or the previous step here, we would get negative 10 plus the square root of 104. And that would be about 0.2. And if I would do the subtract version, I would get negative 20.2. So a couple different ways to get those decimal answers. These two answers would be the best two. Solve each equation with the quadratic formula. Quadratic formula here, first of all, we need it in standard form. So 9p squared, 2p plus 9. Nothing common to come out. My A coefficient is 9, B coefficient negative 2, C coefficient is 9. So my variable P will equal the negative of B plus or minus the square root of my B squared minus 4 times A times C, all over 2A. I'm going to go ahead and simplify my discriminant inside my radical here. So I'm going to get 4 minus 4 times 81. And that's going to give me a negative 320. And down here I get 18. Now because of the negative, I'm going to switch this and squeeze an I there just to save a little bit of work here. And 320 is going to be 64 times 5. So I got kind of lucky there, I spotted that. So I'm going to get 2 plus or minus 8i root 5 all over 18. 2 comes out of the 2, comes out of the 8, comes out of the 18. So I'm going to get 1 plus 4i root 5 over 9. And that's as good as we can get. Messy, but that's the correct answer. Over here, just a little bit of work to get it in standard form, like we've seen before. I'm going to bring this 21 over. No common number goes into each. So my A coefficient, B coefficient, C coefficient. And now my variable x has to equal the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2a. X equals, just a little simplifying here, plus or minus 6 in the bottom. We're going to get 49 plus 12 times 21, because the sign's there. I'm going to get the square root up. 301. 301 is prime. Well, I can't factor that or simplify that with radicals. Now I could here now decimal this out, but this would be a good answer. If I decimal this out, I'm going to get negative 7 plus the square root of 301. All divided by 6. For about 1.7. My other solution would be the negative version of this, or the subtract version I should say, and we're going to get about 4.1. So either of these would be good answers to get.